Hey guys, welcome to day 3 of remote learning. What did we do? Yesterday we did the selection sort, and the day before that the bubble sort. Today we're going to talk the insertion sort. So again, we're going to keep it pretty clean, pretty quick, pretty simple. Click the link up here or in the description to view the video on how the insertion sort kind of works. The whole process is about taking an element from the list and inserting it exactly where it belongs in an already sorted list. So that's going to be our goal. So watch the video. It's going to kind of help you understand exactly what's going on. All right, so you watch the video. Here's the basic setup of how we want to go through this. We've got our insertion sort algorithm where we have some sort of integer array that we're going to be working with. I'm going to keep track of the index of the last element in the unsorted partition, or at least where the boundary is. So right now I'm going to assume that the very first element, if that's the only element in a list, let's say, if there's only one element, it's sorted. So what I'm going to do is keep the left half of the list, assume it to be the sorted partition, and the right half of the list is going to be the unsorted partition. And what I'm going to keep doing is grabbing elements from the right half and inserting it into the correct element, into the correct place of the right or left half where it's already sorted. So since I assume that the first element is already sorted, I can kind of start my counter at 1 because that's where I want to start looking for the element that I want and then placing it into the right spot. So I'm going to set a counter or a variable called I to make it equal to 1. Well, I is less than the length of the integer array because we're going to go all the way through it. We're going to go to every element. We're going to see where it needs to go. Okay. And so my deal here is I'm going to keep track of the value that's stored at in the integer array at position I. I'm going to call it value. I'm going to set j, another counter, equal to I minus 1. So it just goes 1 to the left of where I'm currently at. All right. And my goal is to keep backing that j up as far as I can until I find exactly where value, the integer that came from int array at I, where it belongs in that already sorted partition. So while my j is greater than 0, so I can back it all the way up to the front, okay, and the value is currently less than whatever's at int array at j, okay, so I'm looking for where to place it. While that's true, I want to keep shuffling the items in that sorted partition off to the right, okay, and making room for the new item that I can slide in. And once I've sorted them and kind of pushed them all off to the right just a little bit, I'm going to insert whatever value I had at that newly designated location because there's kind of a duplicate value here. And what I want to do is just slide it in where that value is duplicated, and is that first spot. Once I have it in there, then I can scoot I over by 1 and then start searching again for where that next element should be. So it's all about picking an element out of the unsorted partition and then finding out exactly where it belongs in the sorted partition and just slipping it in there. Okay, so that's what we're going to attempt to do. So let's go over there. We'll take the same logic, we'll code it up, and we'll see what we need to do with that. All right, so we're here. We want to figure this out and start coding up our logic that we had over here on this other page. So the very first thing I want to do is really, this is just a for loop. Okay, we're starting off at 1, going into length of the integer array, and then we're going to keep increasing I by 1 each time. So let's just set that for loop up real quick. We'll go for int I equals 1, I less than the integer array, this dot int array, dot length, okay, or again size in our part. So we can go I plus plus because we want to go through the whole array. Okay. What I'm going to do next is I'm going to grab the value that's at I. Okay, so I can hold on to it because essentially I'm going to replace it with something in a minute here. So I'm going to go int value equals this dot int array at I. And I don't want to lose that value at all as I start replacing it. I'm going to go int j equals I minus 1. So now I'm 1 less than where I'm currently at. So I'm starting to make my way through the already sorted partition. J is the last element of the already sorted partition on the left-hand side of the array. So now I'm going to start running myself through another loop. Okay. And now this is not going to be a for loop. I'm going to keep this as a while loop because I've got a couple of conditions here. I want it to stop when it either reaches the very front or the very first element in the sorted partition, or I want it to stop when the value finally becomes less than whatever's currently at the integer array at j, because then I know where to slip it in. Okay, so I'm going to say while, okay, j is greater than or equal to 0, and my value is less than, and I can't use and, I got to use two ampersands. Whoops, those are dollar signs, ampersands, and my value is less than my this dot int array at j. Okay, while that's true, okay, let's scroll over here. What I want to do is start moving some things down. So if you think about this, I'm going to say int array at j plus 1 equals int array at j. So that's just me taking the element I'm currently on, and moving it over to the element that's in the next spot. So let's do that real quick. So we're going to go int array, this dot int array at j plus 1. Now in the first iteration, that j plus 1 is essentially I, so that's why we had to keep track of value to begin with, otherwise I'd lose it, is equal to this dot int array at j, right? So we've pushed it, and I want to decrease j by 1. Okay, so I can keep moving it down. And this is going to keep happening. I'm just going to keep replacing the next element with the previous until one of these two things comes out false. Then I finally find a value that's less than the value at j, or I run out of room and j becomes negative, because then I won't want to do any more swapping. Now once this loop is finished, okay, that's where I want to actually start putting in the value. And it's not going to be at j, it's going to be at j plus 1, because we've already moved to the left one, and we want to kind of bring it back to where we want to insert it. So we're going to do int array, or this dot int array at j plus 1 is equal to value. And we don't have to worry about moving the I plus 1. The for loop already takes care of that. And there's my insertion sort. This is going to go over and over and over again until I run out of elements in the array. And what I'm going to do is just pick out the element, the first element from the unsorted partition, call it value. I'm going to figure out where it belongs. Okay, and just keep moving things around, and once I find where it belongs, insert it. And so you'll see that this one doesn't even call the swap method that we had before. So again, we're not making a ton of swaps here. We're simply shuffling things down, which is actually a really quick action, and then we're only making one insertion. So again, this one is on par for being just as kind of fast as what this selection sort was, but maybe even a little bit quicker because we're not making any swaps. Okay, it depends on how cluttered and a mess the array actually is, so how far it needs to go, because this loop is very conditional based upon where it should be. So let's run it. Let's see what happens here real quick. So we'll go over to test. I'm not going to do the smart bubble sort here. I'm going to do the insertion sort. Okay, and let's run it. Give it a second to build. And here we go. We have a sorted list starting at 193, working my way up to 984. If I wanted this to go in descending order, then again, all I got to do is flip that inequality sign, and I'm just looking for when the value should fit in there at the appropriate moment for a value being greater than int array at j. So it's actually a pretty quick and easy way to sort a few things. So again, there's the code, the setup for it. So again, that's the insertion sort. Now it's time to get to the assignment. The assignment is the same as what it was the other days. You're just simply going to add the insertion sort to that Java file. I believe you're going to insert the names in ascending order. So just do that, and again, you can submit the same Java file again with this insertion sort. Tomorrow we'll take care of searching the array. So we'll do a linear search, which you've already done a million times, so no big deal. And then we'll do something called a binary search, which is a more efficient search algorithm, but the caveat is the list must be sorted first before we can search it with a binary search. So we'll do all that tomorrow and the next day, and then next week we'll have a live stream to clear any misconceptions up, make sure you take any questions, and we'll be working on lab next week. So we'll take it step by step. Hopefully this is working out pretty well. So we'll see you later.